Good morning. This is Hope Reactor. Now, let's begin today's news.
Can milk reveal how much methane a cow produces? This glass of milk may contain clues about how much methane a cow releases each day, not because the milk itself contains methane. The key is in the pattern of fatty acids, milk yield, protein levels, and other data already collected on dairy farms. On July 28, 2026, a Japanese research team announced a new method for estimating methane emissions from dairy cows without directly measuring every breath. It sounds almost impossible. How can milk tell us something about a cow's burbs? To understand that, we first need to look inside the cow. Cows can turn grass into milk because of a remarkable digestive system. Their first stomach, called the rumen, is home to countless microorganisms. These microbes break down grass and other feed that humans cannot digest. This process gives the cow energy, but it also creates gases, including methane. Most of that methane leaves the animal through belching. Methane is a powerful greenhouse gas, so reducing emissions from livestock has become an important global challenge. Researchers are testing new feed, better farm management, and even breeding programs for cows that naturally produce less methane. But there is one major problem. Measuring methane from each cow is difficult and expensive. One highly accurate method places the animal inside a special chamber, where airflow can be carefully monitored. This works well for research, but it is not realistic for hundreds of thousands of cows across ordinary farms. Another method collects part of the cow's breath while it is being milked. This is easier, but it still requires special equipment. The Japanese research team asked a different question. Could methane emissions be estimated from information that farms already collect? Their attention turned to milk fat. Milk fat is not a single substance. It contains many different fatty acids. Some are closely connected to what happens inside the rumen, including how feed is fermented and how the cow uses roughage. In other words, milk can carry a kind of chemical record of the cow's digestion. The researchers combined the proportions of several groups of milk, fatty acids with data such as body weight, milk yield, and milk protein. Using those relationships, they created formulas to estimate how much methane a cow produces in one day. The method does not mean that anyone can look at a carton of milk and instantly know the answer. It also does not replace direct measurement in every situation, but it suggests that methane differences between cows may be estimated without placing sensors near every animal's mouth. That is where this research becomes especially important. Japan already has a national milk recording system that collects data from dairy farms. Milk yield, fat, protein, and other information have been recorded for many cows over long periods of time. If the new formulas can be improved and validated on a larger scale, existing records could become a huge environmental database. A system originally designed to understand milk production and animal health could also help estimate methane emissions. The same data might support several goals. Farmers could compare feeding methods and see which management choices are linked to lower methane output. Researchers could study why some cows produce less methane than others, and breeding programs could eventually select cows that maintain good milk production while releasing less methane. This does not mean that low methane cattle will appear overnight. Breeding takes time. The formulas must also be tested across more farms, climates, diets, and breeds. The current research was based on data from a limited number of experimental farms. A model that works well in one region may need adjustment somewhere else. So this is not a finished nationwide solution. It is a promising tool that still needs more evidence, but the direction is powerful. Climate action often sounds like it requires expensive new machines, large sacrifices, or more work for farmers. This approach begins with something different. It asks how we can use data that is already being collected. Instead of treating cows only as a climate problem, it looks for ways to improve both environmental performance and dairy production. And instead of demanding that every farm install complex measuring equipment, it tries to turn ordinary milk records into useful climate information. A glass of milk may therefore become more than food. It may become a window into the cow's digestion, a guide for better farm management, and a clue for building a lower-emission dairy industry. The goal is not to blame cows. The goal is to understand them better. With better data, farmers may be able to produce milk, protect their animals, and reduce emissions at the same time. Milk has always told us something about a cow's health and productivity. Now, it may also tell us something about the atmosphere. What do you think? Could milk data become one of the tools that helps farming and climate action move forward together? Let us know in the comments. This is Hope Reactor, where new knowledge becomes hope.